So this is the situation that we need to cover. We have the camera entity at the bottom of the screen, and he begins moving upward. Right? Remember that we modified the camera update method to calculate the x offset using the ship's x position and the y offset using the camera entity's y position. So the camera is following the ship on the x axis. The camera is following the camera entity on the y-axis. So we made the camera a smart camera on the x-axis. Now we want to make it a smart camera on the y-axis. So if the camera entity is here at the bottom of the screen, then what would be our y offset? Right? Well, it would be camera entity's y position. Let's assume the y position is the height of the world. So let's say the y position is 1000, and then we have the wind height divided by 2, and in this example wind height is 600, so wind height divided by 2 is 300. So I'm gonna sorry about that. So I'm going to add 300 to negative 1000, and that's going to give me 700, or I'm sorry, negative 700. Right. And remember, we want to notice that the x offset and y offset of the camera represents the top left corner of the visible screen, x position and y position, with the signs flipped. So the x offset will be negative 100 and the y offset will be calculated to negative 700, and we've proven that here by running the numbers. Right, we get negative 700. And so when we go ahead and run camera apply on all the objects that are blitted on the screen, what we would see is this portion down here that isn't a part of our world, right? And so that's what you folks should have at the moment, a non-smart camera on the y-axis, right, that shows parts of the world that are outside of the world. So we want to fix that. And the way we're going to fix that is we are going to limit the y offset that's calculated to be starting right here. Right? So when the camera entity gets to this position here, which is at 700 on the y, right, then the visible screen would be extended like so. Right? And since our wind height is 600, that would be 1000 minus 600. So this top left corner's y position would be 400, and the top left's x position would still be 100. Alright, so if the camera entity is anywhere from here down to here, we want to set the y offset to what it would be as if the camera entity was here. Right? What would that do for us? Well, that would make sure that the bottom of the screen would always be the bottom of the world. Alright. And so what we need to ask ourselves is, what conditional statement can we use that would describe this situation, right, where the camera entity is from here to here. And so there's many ways you can do it. The way that I can think about it off the top of my head is if the camera entities, maybe we could say if the y, let's think in terms of the y offset. So in between this position and this position here, in between this position and this position here, the y offset, here the y offset is the world height minus the screen height, right? And then here, in this situation, right, the y position, or the y offset, is world height, negative world height plus a positive wind height, negative world height here plus wind height divided by 2. Alright. So what could be the conditional statement that would cover this range, right? Well, we would say if self.y offset is greater than, is that right? Yeah, so as the ship is moving upward, he starts at the bottom and the y offset is negative 700. The ship moves upward and his y offset increases, right, until it gets to 0 at the top of the screen, right? So we have negative 700, it moves up, negative 600, negative 500, negative 400, and so on until we get to the top of the screen where the x offset would be equal to 0, right? So it is increasing as we move up. So we're saying if the self.y offset is, let's see, is it greater than or less than? Right. If it is less than, right, less than this expression here, right, where the camera entity is, where the bottom of the visible world is the bottom of the visible screen is the bottom of the world, right, and that's this situation, which means the y offset would be this expression. So if the y offset is less than negative world height plus the win height, then we want to stick the y offset to that expression. So we're going to say y offset is equal to that expression, right? And if you add that to your the update branch in the update that makes your camera a smart camera, then suddenly when the camera entity starts at the bottom of the screen, it will not show parts of the world that are outside of the screen because the y offset will be stuck at negative 400. Right. When the camera entity is here, until when the camera entity gets to here, the y offset will be stuck at negative 400. Right. And then if the camera entity continues moving upward, then the y offset will be calculated using this expression, because this condition will not be true. Right? The y offset will not be less than this line here. Right? Oh, I'm sorry. No, less than this line here. Right? It will be greater than, because as we move up, let's say the camera entity moves up 100 units, that means the y offset is now negative 300, which is less than negative 400. Right? And this expression here is not true. So that is how you create the smart camera on the y-axis at the bottom of the world. The next problem, once you get this worked out, is how to make the smart camera at the top of the world.